over the next method for solving systems of equations, which is elimination. We've already gone over two types of ways to solve a system. We've gone over, you can graph them and you can figure out where those two lines intersect. You can use substitution, and now we're going to go over elimination. We're going to use elimination to determine where two lines intersect. When you use substitution, it was nice if the equations were in slope-intercept form. When we're going to use elimination, it's nice if the equations are in standard form. It's nice if the x's are lined up, the y's are lined up, and the numbers after the equal sign are lined up. The reason why? We're going to combine these two equations together and hope that one of the variables is eliminated. Once one of them is eliminated and we find that one, then we can find the other variable, and then we have our ordered pair or our point where those two lines intersect. Our first example, we need to make sure these things are in standard form, or the most important part about standard form, we need to make sure all these variables are lined up. Make sure the x's are lined up, make sure the y's are lined up, make sure these numbers after the equal sign are lined up. Because according to our rules, we're going to combine these together, these two equations, and we're going to hope that one of the variables is eliminated. So, remember there is a 1 in front of this x, so this is 1x plus 7x, that gives me 8x. When I combine a negative 10y and a positive 10y, the y's are eliminated. I'm taking these two equations, putting them together, and making a third equation. This third equation right down here is not going to have any y's in it, because if I take a negative 10y and a positive 10y, put them together, I have no y's left over. I bring down my equal sign, I combine these together, and I get 16. Once I solve this small one-step equation right here, I'll have my x-coordinate. So let's divide both sides by 8, and I determine that my x-coordinate is equal to 2. 16 divided by 8 is 2. I've got half of the point where these two lines intersect. Now I need my y-coordinate. The way I'm going to find my y-coordinate, I'm simply going to take that number and plug it into that top equation right there. Once I do that, here's what this equation looks like. 2 minus 10y is equal to 2. I need to solve this for y. Subtract 2 from both sides. Negative 10y is equal to 0. Divide both sides by negative 10. Y is equal to 0. 0 divided by negative 10 is 0. This is the point right here where these two lines intersect. I always start off by trying to just push these two equations together. I'm pushing those two lines together and determining where they intersect. When I push them together, I hope that one of the variables is eliminated. So let's try this again. This is asking me to solve this using elimination. I need to make sure the x's are lined up, the y's are lined up, and these numbers after the equal sign are lined up, and they are. That means I'm ready to push these two equations together and create an entirely new equation, a third equation. X and x combined together give me 2x. A negative 5y and a positive 5y combined together, that means the y's are eliminated in this new equation. Bring down my equal sign. 28 and a negative 12 combined together, 16. I solve this, and I find that my x-coordinate is 8. Now I need to find my y-coordinate. How do I find my y-coordinate? I take this and plug it into that top equation. When I plug it into that top equation, here's what it looks like. 8 minus 5y is equal to 28. I need to solve this for y. Opposite of positive 8, negative 8. Negative 5y is equal to 20. Divide both sides by negative 5. Y is equal to 20 divided by negative 5 is negative 4. That's my y-coordinate. This right here is the point where those two lines intersect. So my process for using elimination, Make sure it's in standard form, or at least make sure the x's and y's, equal sign, numbers after the equal sign are all lined up. Combine those together, those two equations together, hope that one of the variables is eliminated. But what if you try to combine these together and one of the variables is not eliminated? So if number 2 doesn't work, then you need to change the signs of the bottom equation and try again. So if you're trying to combine these together and one of the variables is not eliminated, simply change the sign of everything in the bottom equation and try again. Then combine them together and see if one of the variables is eliminated. We're going to do an example of one like this. Here's an example of a systems of equations that when we push them together, one of the variables is not eliminated. 9x and 9x put together gives me 18x. 8y and 10y give me 18y. So when I try to push these two equations together, the x's are not eliminated and the y's are not eliminated. So what I'm going to try is this. I'm simply going to change the sign of everything in this bottom equation. So let's do that first. Change the sign of everything in this bottom equation. I'm going to bring this other equation over, set it on top of it, and now I'm going to try and combine these two equations together and hope that one of the variables is eliminated. Which variable is eliminated? The x's, because this is a positive 9x and this is a negative 9x. So this new equation I'm about to write down will not have x's in it. 8y, negative 10y put together, negative 2y. 3 and negative 15 put together, negative 12. I need to divide both sides by negative 2. My y coordinate is going to be 6. A negative divided by a negative is a positive. So, as far as my answer goes, I have the y coordinate for my answer. I need to now find the x coordinate for the point where these two lines intersect. What I'm going to do is I'm simply going to take this and plug it into this equation right here. So let's see what that looks like when I do that. 9x plus 8 times 6 is equal to 3. 8 times 6, 48. I need to subtract 48 from both sides. 9x is equal to 3 and negative 48 put together, negative 45. I need to divide both sides by 9. X is equal to negative 5. This is the point where these two lines intersect. If you try to use elimination, you try to push these two together and one of the variables is not eliminated, then change the sign of the bottom one and then go through the process of pushing them together, just like the other ones. Let's try another example of that. I need to use elimination to solve this system. So the very first thing I want to do is I'm going to try to push this together and see if one of these variables is eliminated. 5x and 5x put together, 10x. Negative 3y, negative 6y put together, negative 9y. So right now, pushing these two equations together does not eliminate one of the variables. That means my first step, change the sign of everything in the bottom equation. Bring this top one over, set it on top of this other equation. And now we're going to push these two together and see if a variable is eliminated. Which variable is eliminated? This x right here. 5x and negative 5x, that means the x's are eliminated in this new equation I'm about to write down. Negative 3y, positive 6y gives me positive 3y. 20 and 10 put together give me 30. Divide both sides by 3. I found out that my y coordinate is 30 divided by 3, 10. So I'll go ahead and make an ordered pair over here. And I put this in the y spot of that ordered pair. The only thing I'm missing now is my x coordinate. The way I figured out what my x coordinate is, I take this number and I plug it in right there. Let's see what that equation looks like when I plug it in there. 5x minus 3 times 10 is equal to 20. Negative 3 times 10, negative 30 is equal to 20. Opposite of negative 30, positive 30. What do I need to do to both sides here? Opposite of multiplying by 5, dividing by 5. X is also equal to 10. So I put that in the X spot. If you try to put these together and one of the variables is not eliminated, then you need to change the sign of the bottom one and go through this process here of finding the point where these two lines intersect. So again, make sure it's in standard form, or at least the x's and the y's are lined up. Try to combine them together. If combining them together does not eliminate one of the variables, then change the sign of the bottom one and then push them together and eliminate one of the variables. However, if this doesn't work, then you have to go to this fourth option. If 2 doesn't work and 3 doesn't work, then you're going to need to multiply the bottom equation by something so that one of the variables is eliminated. I'm going to use elimination to solve this systems of equation. If I use elimination, the first thing I'm going to do is try to go ahead and push these together and see if one of the variables is eliminated. So a 2x and a 4x, that gives me 6x. 2y, negative 6y, that gives me negative 4y. So neither the x's or the y's are eliminated. If I change the sign of this, if this was a negative 4x, would it eliminate that? No. If this was a positive 6y, would it eliminate that? No. For it to eliminate, the numbers have to be the same and the signs have to be different. So for some students, this is where elimination gets difficult because you have to decide which variable you want to get rid of. I'm just always going to try to get rid of this first one and see if it'll work. So for this to eliminate right here, it would be nice if this top one right here was what? What is the opposite of 4x? The opposite of 4x? Negative 4x. So what can I multiply? Because I'm going to have to use multiplication to change this equation right here. What can I multiply to this top term to change it into negative 4x to eliminate this bottom one? What can I multiply the 2x to change it to negative 4x? I need to multiply this entire equation up here times negative 2. I want to multiply everything by negative 2. So here's what this equation is going to look like when I do that. Negative 2 times 2x, negative 4x. Negative 2 times 2y, negative 4y is equal to negative 2 times negative 6, positive 12. And the reason I did that is because I'm going to move this other equation right below it. And look what variable is eliminated, the x's. So what I did was I started off by trying to combine them together. Changing signs of the bottom one didn't work. So I need to multiply the top one or the bottom one by something. So I just started right here at the very beginning. I said, hey, if I multiply this top one by negative 2, it's going to change it to a negative 4x so that when I combine it with the bottom one, the x's will be eliminated. So I want to make my new equation where the x's are eliminated. Negative 4y, negative 6y, negative 10y is equal to 12 and negative 2, 10. What do I need to do to both sides here? Divide by negative 10. Y is equal to negative 1. Then I simply take this and plug it into any equation I want to. I want to plug it into this one right here. Here's what it looks like when I do that. Negative 4x minus 4 times negative 1 is equal to 12. A negative times a negative is a positive. Opposite of positive 4, negative 4. Negative 4x is equal to 12 minus 4 is 8. Divide both sides by negative 4. X is equal to negative 2. So I've got my x coordinate, -2, and I've got my y coordinate, -1. Again, for some students, it's difficult to know what to multiply the top one by or the bottom one. It doesn't always have to be the top one. You have to make a decision, because I could have also multiplied this top one by 3. If I multiplied this top one by 3 right here, that would eliminate the -6y, because multiplying it by 3 would change that to a +6y. So you need to look at the top one or the bottom one and make a decision. And I can't tell you every single time what to multiply it by. You're going to have to look at the equations and go, hey, do I want to get rid of the x's or do I want to get rid of the y? To get rid of the x's, I had to multiply by -2 to eliminate this one down here. To get rid of the y's, if I wanted to work this problem completely differently, I'd still get the same answer. To eliminate the y's, I would need to multiply this by 3. So that's what's going to be difficult. One more example where we have to multiply. When they give us a problem and they say use elimination, the first thing I want to do is try to just put these together and hope a variable is eliminated. Right now the x's are not eliminated, the y's are not eliminated. Maybe if I change the sign of the bottom ones. If this was a -x, would it cancel that out? No. If this was a +20, would it cancel that out? No. So what I do is I just start here at the very beginning. What would I want this bottom to be right here to cancel out that 2x? I would want this bottom to be -2x. So what I'm going to do is I'm going to multiply this bottom one by -2. And I'm going to change this equation. -2 times x is -2x. -2 times -20, +40y. -2 times -13, +26. I'm simply going to write this one right over it. 2x minus 10y is equal to 4. I'm going to combine these two together. When I combine these two together, what's going to be eliminated? The x's are going to be eliminated. -10y and +40 give me 30y. And 4 and 26 give me 30. Divide both of these by 30. Y is equal to 1. I'm going to take this and plug it into this equation right here and change this top equation to 2x minus 10 times 1 is equal to 4. -10 times 1, -10. Opposite of -10, +10. Opposite of multiplying by 2, dividing by 2. So now I have the x-coordinate and the y-coordinate where these two lines intersect. So my answer is this ordered pair or this point right here.